All right, we're going to be looking at Hooke's law. All right, now when we look at Hooke's law, what we're going to do is we're going to go ahead and we're going to look at this spring. And what's going to happen is I'm going to put different masses on here. And as I put the masses on, it's going to cause the spring to stretch a little bit. All right, and as the spring stretches down, we're going to look at how far it stretches based off of how much mass I put on here. Now, the idea is I'm going to put it on and I'm going to let it come to an equilibrium. I'm not going to let it bounce around, okay? So at this equilibrium point, then whatever the force of gravity is down on this mass, that has to be equal to the force of the spring up on this mass. And so by doing that, we're going to compare the displacement of the spring, how far down it's stretched, and we're going to compare that to the amount of force that's being pulled down on the spring, and therefore the amount of force that the spring is pulling upwards with. All right, so that's what we're going to be looking at right now. So I've kind of explained what's going to happen, and I'm going to put all this data into a spreadsheet, which I'll show you in just a second. Okay, I'm just using my common everyday meter stick here, and I'm going to measure the bottom of the spring right here. So with that, we're going to go ahead and get some data. All right, but literally I'm just going to do this. It's starting here at 34.1 centimeters. And so when I put this guy on, it's going to go down to right there, 32 centimeters. And so that's going to be the first point in my table. You'll see that in a second. Then what I'm going to do is I'm going to add a 20-gram mass on. Initially, it says here that it's 50 grams. And so I'm going to add a 20-gram mass on. Actually, I'm going to add a couple of them, just so we'll go a little bit quicker with this. So we'll add on 40 grams. And then we'll measure the new height. So the new height is at 30.4 centimeters. All right, and so that's how we do it. All right, guys, so you can see here the spreadsheet we'll be using. I'm going to put all the data that I just gathered in here. All right, now you'll notice that what I did is I've got a column here for the position. So that's what I put in initially, right? We initially measured that it was 34.1 centimeters. That was the position of the spring before it started stretching, right? And so I put that in, and what you'll see up at the top is that eventually it'll give me the displacement. It'll do that 34.1 minus whatever I have in cell A3 there. That's what it's going to calculate here. So remember, when I put the 50-gram mass on there, it went down to 32.0. And so you'll notice it automatically calculates in centimeters for me. All right. Now that centimeters, of course, I want turned into meters, and you'll see that over here on the far right-hand side, where it's going to put the displacement there, and it's going to be 0.021, which is because it's that B3, that centimeters divided by 100, which will give me the number of meters that I've got. All right. Now, I'm also going to be able to get the force. Remember, that first one that we measured was 50 grams. So if I put 50 grams in there, notice that it calculates the force for me. Remember, the force here is the force of the spring, but because it's at equilibrium, that's equal to the force of gravity. All right, and so as we calculate that, we're going to take those 50 grams, divide by 1,000, that'll turn into kilograms, and then we'll multiply by the acceleration due to gravity, which I put in as 9.8. It's going to be close enough for our uses here. All right, and it gives me the force. Now that automatically puts the point, you can see right here over on the left-hand side, that automatically puts the point over on my graph. All right, and so we're going to go ahead and we're going to try to finish this up, and we're going to try to put a few more points in there. All right, so what I'm going to do now is I'm going to add in 2 more masses, and I did this in the previous slide, but as I add in 2 more masses, you will see it now goes down to 30.4 centimeters. So we'll type in 30.4. Those 2 masses are 20 grams each. And so this then we'll go ahead and say that that is 90 grams. And so there you see we got another point there. We'll add on a couple more. Oops. Sorry. There we go. We add on a couple more. And so now we'll measure it again. And so now we've got it to 28.8. So we got 28.8 and then 130 grams. And so that adds in another point for us. Let's go ahead and add in another one. So we'll add 2 more of these on here. So that's another 40 grams. And again, we will measure our height to the lowest ring. We've got 27.2. And so we add in another 40 grams there. So that's going to be 170. And that was at 27.2. We add in another point there. And you can already tell this is a very nice linear graph here. Let's go ahead and add on it. We'll do a couple more of these just so that we have a nice clear graph. So here's another 40 grams there. And we measure it. And we've got 25.7, it looks like. So 25.7 and now up to 210 grams. Very nice. We'll do maybe 2 more, throw them in there. You can still see that it's pretty clearly nice and linear there. All right. Again, remember, I don't want it to oscillate. I just want it to sit there. Let's see. So we've got 24.1 this time. So we'll go 24.1 and we'll go up to 250 now. And we'll add on 1 more. I think I can get 1 more on my mass here. So we'll go ahead and put that on. We'll measure. We're down to, stop swinging around, buddy. About 22.4, I'd say there. So we'll go 22.4, and that was a 290 grams. And so you can see pretty clearly here that we've got a very nice linear graph, okay? Obviously, there's some real stuff going on there as well. The marker at the top may start bending a little bit, and we may get some minor difficulties there. But for the most part, we can get a pretty good graph there. If I click on this, then we should, I'm going to go ahead and I'm going to shift all this data down 1 because we actually did have another data point. All right, there we go. So I put the masses in correctly as well, and you see now that we have a nice, clean, straight line. I can actually go in there and say, hey, can you please give me the equation right there? And that number right there, 24.5, that would be the spring constant, the K. Right? You can notice that our y-intercept there is basically 0. Okay, that's compared to the other y values here. It's pretty small, right? 0.01 newtons. So basically 0. And so we can use that as then our spring constant. And that's basically Hooke's law. It's just saying we increase by a certain distance and it will be a proportional relationship with the change in force. That's it.